In the previous session, we understood about what is class, what is objects, how to create a class, and how to create an object. But in this session, we understand about what is constructors, why do we require constructors, about the init functions, and the next concepts of object-oriented principles, which is polymorphism, inheritance, and encapsulation. To start with, let us revise what is a class and what is an object. We understood that when we say that we have a class, the class is just a blueprint. We say class, the class is the blueprint. What we understand when we create a class, something like this: class animal. When we create a class by name animal, the compiler understands, oh, it is a blueprint. It says that yes, so there is something inside it. What is something? There is attributes and behavior. Whenever we say class, the class has two things. One is called as attributes, another thing is called as behaviors. So any class for that matter will be having attributes and behaviors. We've understood this. When we say attributes, the attributes are nothing but the state and the behaviors are functions. We understood this very well. So for a revision, we have a class animal, then we can define an attribute as name, then we can define attributes as name is equal to blank, then we can define a function by name def play, then we can write it as print animal is playing. The simple class what we create. If you want to create an object of it, what to do? Let us create an object of this class. Okay, to create an object of this class, what we can do is we can say something like a equal to animal. So what happens here? What happens here is animal object gets created. So there is a memory. We understood how the object's memory gets initialized. Then we can call something like a dot play. So we call a dot play. What happens? The compiler will look for a, is an object of animal. It goes to this animal class and call the play function. And we can also say a dot name. We'll be getting blank now because nothing is there in the name as of now. The simple concept what we understood. The next important concept what we need to understand now is the constructors. Let us understand what is constructors. Basically, whenever we say that, okay, so we have a class and we have an object or whatever it is, okay, the most important person, the most important concept or the functionality which gets into the picture is the constructor. What is this constructor? The constructor is the first concept or the first principle, we can say, which gets called automatically whenever an object is created. You didn't get? Let us go to real world. Assume that you have a blueprint of the house. You have a blueprint of the house. You say here there comes a kitchen, here comes the living area, here comes the master bedroom or something like that. You give this blueprint. You give this blueprint to your constructor. Who? Your engineer. You give this to engineer. The engineer implicitly calls someone called as a constructor, a building constructor. What does he do? He looks to this plan and he understands how to be constructor. Then he makes the space accordingly. Then he comes into real world existence. Whatever the blueprint have, it comes to real world existence. This fellow who is a constructor will involve and he constructs the house. This constructor will construct the house. Just for an example, I told this. The same happens even in our programming. Whenever we have a class, this class has to be converted to object. If this class has to be converted to object, the first fellow who gets involved is called as constructor. So constructor is the first concept which gets involved whenever we convert a class to an object. You mean to say, so whatever we created till now, the constructor was getting called? Yes. When we created a is equal to animal, internally constructor was called? Yes. What is called as? It is called as default constructor. What do you mean by default constructor? This fellow gets called automatically without your knowledge. Okay, is getting called automatically without your knowledge. This is called as default constructor. You mean to say that we have one more constructor also apart from default constructor? Yes, which is called as parameterized constructors. We come to that. But we have two type of constructor, the default constructor and parameterized constructor. Okay, now the import parameterized or parametric constructor or parameterized constructor we can call it as. Okay. Now what we need to get a glance is, what is constructor? The constructor is a concept which gets called automatically whenever an object is created. Mean to say, the constructor is a concept which is by default called whenever we create an object. Okay, so why this constructor is required? The constructor is required to construct an object. I repeat, the constructor is equal to construct an object. So now the question is, whenever you create an object, the constructor is getting called? Yes. Whenever you create an object, by default, the constructor is getting called implicitly. Okay, how many number of constructor gets called? How many number of classes you are calling? That many number of constructor is getting called implicitly. I repeat, how many number of constructor is getting called? How many number of classes you are calling? That many number of constructor is getting called implicitly. We see that in detail. Before that, just have a glance that the constructor is a concept which gets called automatically whenever an object is created. So now the question is, how will the constructor look? When it will get called? How it is defined? Let's see all these things. Let's take the same example of animal class now. We have a class by name class animal. Let us recreate it. If we have a class animal, and inside this class animal, I'll write the first function which is constructor. I'll say def init double underscore init. Why this double underscore? We'll see this later. Okay, just follow this double underscore init, and the first argument, whichever we define, whichever the functions we have inside the class has to be self. We know this very well now, right? So self. Then I say it as print constructor called. I say print constructor called. Just a simple class. I say constructor called. That's it. Now I'll try to create an object of this particular class. I say a is equal to animal. Now when I say a is equal to animal, I have not called any function, but automatically you will be getting an output as constructor called. The output would be constructor called. If you ask me, how is it so? How is it so? Because you have defined the init constructor. You have defined the init constructor. Yes. The init constructor automatically called whenever you create an object. When you create a is equal to animal, even though you are not calling this a dot init, you're not calling like a dot init, but automatically this a dot init is called. How? Because you called the constructor. Because you created an object. When you created an object, internally an object calls this constructor. This we need to understand. Now the question is, why do we require this constructor? We'll come to that point. Let's take one more example. We have something like class animal. Then we have the name. Let me say the name of the animal. We say name is equal to blank, nothing. Then we have something like def. Okay, and I have something like play. I have def play. Def play, and the first argument let it be self. Def play self. Then we say print animal is playing. Okay, animal is playing. I just say animal is playing. Okay, and I say self dot name. As of now, you must understand what is this self dot name. Why the self dot name comes into picture? Because it is the class variable, right? Name is a class variable. Whenever you want to call the class variable, the self is compulsory. When you're calling the function variable, self is not required. But when you're calling the class variable, self is compulsory. So we did self dot name. Now I create an object of animal. I say a is equal to animal. A is equal to animal. Now I say a dot play. What will be the output? The output would be animal is playing and a blank. Why blank? Boss, you are not initialized this name. You forgot to initialize. Oh. Even though there were attributes inside the class, you forgot to name the attributes, or you forgot to give the values to the attributes. You forgot to set the values to the attributes. That is a very big mistake. To avoid that, you would have defined a constructor. Inside the constructor, we can initialize the attributes. Very important. I'll define it. Very important. Inside the constructor, we can assign the attributes. We can assign the values to the attributes. We can assign values to attributes. This is the most important point where we use constructor for. Assign values to attributes while what? While creating an object itself. While creating object. That is, while creating an object itself, we can assign the values. We can assign the values to our attributes. This is the most powerful technique what you have in constructor. This we need to understand. That is, when you have an animal class, here, the name was not defined. You just made name is equal to blank. You forgot to give the name of the animal. But You can assign, would have assigned the name by creating an object itself. This is why the space is left for you. People who had this confusion now must get clear. This space, this argument space is reserved to send the attributes to pass for your class. While creating an object, you want to assign the name, you can pass it here. You have one more variable by name age, you can pass here. You have something like pet name, you can pass it here. Whatever the attributes you have inside your class can be initialized while creating an object itself. That's the power of constructor. So now the next question, how to do that? We'll see now. Let's understand how to pass the arguments for the init function. We'll recreate the same class animal. Class animal. Def init. So def double underscore init. This is how the constructor looks. The first argument is self. The second argument is name. And here I can define something like name is equal to blank. I don't have name which is initialized. Okay, so inside this constructor I take this name and I say something like self dot name is equal to name. So what happens is, whatever the argument which was cast here, which is his name, is assigned to this self dot name. What is self dot name? The class's name. Which is class name? This is this one. I'm accepting the name. That name I'm giving back to self dot name. Okay, then I define something here as def play, a simple function def play. I say here as let me say print animal is playing. Animal is playing. Animal is playing. Then we say self dot animal, self dot name. Sorry. So self dot name. Okay. Now we create an object of animal. I say a is equal to animal. The animal object is created. But when you just do this, you'll be getting error. You'll be getting error. Why error? Because the compiler says boss. Here you are creating an animal object. Animal object, you only created a constructor. This constructor is accepting a name, but while creating an object, you are not passed the name. It is blank. You would have given a name, right? Because you have only defined a constructor. If it was a default constructor, if I was only creating the constructor, I will create, I don't accept any argument. But you have created a constructor, you have created a custom constructor or else a parameterized constructor where you are saying that it is accepting the name, but you're not passing the name while creating an object. Oh, that is the error. So what to do? What you must do is, you must say something like a is equal to animal, then give the name of the animal. Let me say some Ruby. This is the name of the animal. Now what happens? What happens is the animal object is created. As soon as the animal object is created, we know the first functionality which gets called automatically is your init. This init is accepting the name. You're passing the name which is Ruby. This Ruby is being taken here and it is giving to your self.name. That is, this name is assigned to Ruby. Now if you say a.name, then output would be Ruby. This we need to understand very well. This concept is called as constructor. That is, the constructor is used to assign the values. Whenever you have the attributes which is defined and you have to assign the values for the attributes, you can use constructor. So constructor is the first person which gets called automatically, or the constructor is I say as person because I'm comparing to the real world. Okay, you can just say it as a functionality. Okay, the constructor is a functionality which gets called automatically whenever an object is created. See, animal of Ruby. So this Ruby which gets called in this name and it gets called automatically. Okay, this concept is called as constructor. Now the question comes, okay, so how many arguments can we pass inside this constructor? N number of arguments can be passed inside this constructor. There's no limit with the number of arguments. Okay, but those whatever the arguments you have has to be defined here, right? Like or else it does not make any sense. When you have here as name, age, color or something like that, then you can accept name, age, color, then you can initialize internally. But the problem that previously we understood that name, what we had, we left out the name as blank. But now the compiler is forcing us to say, boss, you have the compiler, the constructor is accepting the name, you have to pass the name for sure, or else it will be an error. This concept is called as constructor. This we'll see practically so that you'll get a better understanding of how the constructor gets into the real world entity, and you'll understand how exactly the constructor gets called programmatically. Let's start seeing the practicals behind what is the technique behind constructors and how it works. Class animal. I'm creating a class animal, and I'm creating a name attribute by name, which is again a blank. Then I create age, which is again blank. Okay, then I say def followed by double underscore init. The first argument is self as expected. Then we say print, the constructor gets called. Constructor called. I'll just run this. Now I create an object of animal. I say a1 is equal to animal. Then I see, okay. So before going to next step, when I say a1 is equal to animal, I didn't call any function, but automatically the output what I got here as constructor called. That's the beauty of constructor. That is, I just created an object, automatically the constructor is getting called. Great. Okay, I'll create something like def play. Then I say self. Will you get the play method? Will you get this play method? No, right? Because play method is a custom function what you have created. I say animal is playing. Animal is playing. I just do this. I go a1 is equal to animal. This function get called? No. But how come this init getting called? I told you, right? This is called as constructor. This is called as constructor, the default constructor. Now the question was, what is the use of this constructor? Yes, I told you, you have a1 is equal to animal. Now I say, okay, animal is playing and name of the animal is, I'll put a comma here and I say animal is playing and I say and name of animal is, then I say self.name. And very important, whenever we want to call the class variables, we must use self. When you want to call the function variable, no self is required. When you want to call the class variable, the self is always required. So I given self.name. Now I'll just run this. Now I say a1 is equal to animal, the constructor which gets called, then I say a1 dot play. See, animal is playing, a name of animal is, oh, it's blank. Why? Boss, you didn't give the name for the animal, you forgot. Yes. Why the constructors are there? Because to avoid this kind of mistakes. Because you didn't give the name, you didn't give the age, it was your mistake. You would have given the name and the age while creating an object itself. Oh, how to do that? How to do that is redefine your constructor in such a way that it accepts the parameter which is the name and the age. How is it so? You have self here, right? Put a comma and say name, put a comma and say age. If you're getting confused, I say name1 and I say age1. Then the same name1 age1 what I'm accepting here, I will assign it to self.name. That is self.name is equal to name1. Self.age is equal to age1. Beautiful. Okay, now I'll run this. Then I'll try to create an object of animal. I say a2 is equal to animal. I'll create a2 is equal to animal. So when I say a2 is equal to animal, which I created now, if I run this, what happens? What happens? It shows error. It says boss, init is accepting two parameters, which is the name and the age, which is name1 age1. You are not passing it. While creating an object, you would have passed the name1 and age1. You are not doing it. That's a mistake. That is, the compiler is forcing you to pass the name and the age. Now I'll pass something like Ruby. Then I'll pass as 6. Okay. Now it says constructor called. Now if you say a2 dot play, a2 dot play, you say animal is playing and name of animal is Ruby. This is simple concept of constructor. We need to understand this. So how many arguments can be passed for this constructor? N number of arguments can be passed. Let me say that I can pass here as color. It will accept. But you need to pass a color here. Let me say it's black. I'll just redefine. It does not mean to say that just because you are passing the color, it must it must assign somewhere. No. You need to understand this. It is accepting black. You are passing black here. It is accepting the in color. It does not mean that color has to be assigned somewhere. No, it is not a rule. But how many number of arguments? N number of arguments can be passed. This you need to understand. Okay, now the question comes here. Okay, so how many number of init constructor can be called? I mean, how many number of init functions can be defined? Let me say, I'll create one more diff init. Is this an error? I say diff init and I say self. Then I say print. One more init. One more init. I just defined like this. Now I'll just call. Is this error? No, you didn't get any error, right? You didn't get any error. I'll create this. You stay. It says init takes one positional argument, but 4 were given. Correct, right? See, it says init is actually one positional argument because it is this previous init is no more valid for my compiler. It says, boss, you are defined init. I agree. But whatever the init you defined previously is no more valid because you are defined two inits. One init what you defined previously was having the argument name, age and color, but it is no more valid. You have created one more init constructor, one more init function which is having no arguments. Which you need to understand. This you need to understand. Okay, it's not an error. It's not an error. But if you're not supposed to pass the argument, okay, you mean to say I will not pass any argument now. So what happens? Let me check. Of course, absolutely fine. No worries. Because this previous init is no more valid. One of the catch point what you need to keep in your mind. This is the concept of constructor. So constructor, what is constructor? It's a functionality which gets called automatically whenever an object is created. Point number one. Point number two, why do we require constructor? We require constructor to initialize the variables and the attributes while creating an object itself. Point number three, how many constructor can be called? There are n number of constructors can be called, but the most recent constructor gets called automatically by the compiler. These are the key points what you need to keep in your mind about the constructor concept. This is the first part before we starting with the object oriented programming. Before we go with inheritance, we need to understand about this constructor. So this is all about the constructor what we need to understand. The next concept would be the most important principle of object oriented principle, which is inheritance.